This video, we're going to learn how to balance chemical equations. So now if we look at a chemical equation like this one, N2 plus H2 makes NH3, the coefficients are going to be the numbers in front of the chemical formulas. So in this case, it's a blank, a 3, and a 2. The blank is always assumed to be a 1, so we can write that in. So it's really a 1, 3, and a 2. So what it says is that one N2 molecule will react with 3 H2 molecules to make 2 NH3 molecules. It can be thought of as literally, like I just did, molecules. It can be thought of as moles, which is a specific amount of molecules, which you know about, or as a ratio. As long as the ratio of molecules is 1 to 3 to 2, the chemical equation will work now, or is balanced. We need to do a quick review before we go on any further in figuring out how many of each type of atom are present, because you're going to need to know that in order to balance chemical equations. So when you look at something like this, 3H2O, this 3 in front is going to, think of it like this, it is going to multiply the entire H2O by 3. So instead of 2 H's and 1 O, you're going to have 6 H's and 3 O's. Same thing would happen here with 2 Km MnO4. So you're going to have 2K, 2 Mn, and 8 O's. This next one, so the thing to pay attention to here is there's a parentheses, and then there's a 2 outside the parentheses. So what this 2 does is it doubles everything in the parentheses only. So in chemical equations, if they don't write a number, we assume that it's a 1, so I'll put the 1 in there. You don't have to write it in. And since Mg is outside of the parentheses, this 2 doesn't affect it. So there is 1 Mg in this equation. There is 2 Ns because this multiplies that by 2. And then there is 6 oxygen. This next one, again, the outside 2 doubles everything in the equation. So we really have 4 Na, 2 S, and 8 O. And then for this one, it's got a little bit of everything. Remember, this 2 outside doubles everything in the equation, but then this 2 in the outside the parentheses will only affect the things that are in the parentheses. So let's figure this out. We can do the easy one first. There is 6 Mg because there's 3 of them here. This 2 doesn't affect them, and then this 2 does. Then there are 2 P's, right, because there's an unwritten 1 there, but then we double it from the 2 outside, so there's really 4 P's. Then we have 8O, because this 2 doubles the 4 to an 8, and then this 2 doubles it again, 16O. So hopefully you followed along with that. We're going to need that for balancing. You're going to have to be able to figure that out. Now, as far as the rules for balancing, here's what I do. I look at the atoms on the right side of the arrow and the left side of the arrow, and my goal is to use coefficients to make them equal. This is the law of conservation of matter. We say that matter can never be destroyed. So if you think about it, if you start with, let's say we look at this equation, if I started with 2 H's and 2 O's, then I'm going to have to end with 2 H's and 2 O's, but I don't. I end with 2 H's and 1 O. Now, I can't simply just put a 2 here and make it 2 O's. That would balance the equation, but that wouldn't make the right product. In other words, H2O is water. H2O2 is peroxide. They are not the same thing. So if I just put a 2 there, I'm going to change the equation and it's not going to be right. So what I'm going to do is I'm going to use the coefficients, which are multipliers. That's what these numbers in the front were. Okay, and I'm going to adjust them. I'm going to assume they are all 1 to start with, and then I'm going to adjust them to make them balanced. So the way I like to do it is simple. The arrow is your universal equal sign. You are going to take an inventory. That's what these numbers are here for. So how many H's are on the left of the arrow? Well, I look and I say there's 2. And then I say, okay, there's 2 O's on the left. Now I go to the right. There's 2 H's on the right. There's 1 O on the right. So think of this like a game of whack-a-mole. You find a problem and you fix a problem. So the problem sticks its head up, you whack it back down and fix it. Okay, so there's only one problem here. I need to make this a 2. I can't just put a 2 there because it changes the chemical equation. So what I'm going to do is put a 2 here and multiply the entire equation by 2. So watch what happens. I fixed one problem, so now I have 2 O's if I do that, but I then created another problem. I will have 4 H's as a result. Okay, so I fixed one problem, now I'm going to solve another problem. Now the H's are out of balance, so I go back to the other side to fix that. How do I get 2 H's here, or 4 H's here? I put a 2 there. And then that's a balanced equation. We have 4 H's on each side, we have 2 O's on each side. It's that simple. The blank will be a 1, that was the assumption we were making in the beginning. And then sometimes you'll get questions where they ask for the sum of the coefficients. So the sum is just addition, so if I just add 2, 1, and 2 together, the sum of my coefficients will be 5. So that's a super simple balancing equation. That's how they're done. You are always going to want to keep an inventory, okay? Especially in the beginning. As you get better at this, you may not need to keep track as strictly, or you could do it in your head, but in the beginning, I want to see the inventories every time. So let's do another one. This one's a little harder. So there's carbon. There's 1 carbon on the left, there's 4 hydrogen on the left, and there's 2 oxygen on the left. Now I'll do the right. There's 1 carbon, there's 2 hydrogen, and notice there are 3 oxygen. So the oxygen is here and there, and they are going to have to be added together each time in order to figure out the total oxygen on the right. Now, since oxygen is clearly the most complicated, because if I change any one of these, I'm going to change the O number, right? Save it. Don't do it first. Do it last. Anything that presents itself as being overly complicated, we save until the very end, because usually by balancing everything else out, we can solve the more complicated problem or make it much easier to solve that way. So start with a problem that isn't oxygen. In this case, the only other issue is hydrogen. So in order to get 4 hydrogen on the right, I put a 2 there. So that brings my hydrogen up to 4, but it will also bring my oxygen up to 4 now, because I have 2 here and 2 there. So now the only problem left is the oxygen problem. I need 4 oxygen on the left side. So I have 2. So if I just put a 2 there, I fixed my oxygen problem. So the balanced equation would be 1, 2, 2, 1. The sum of the coefficients would be 6. So that's how you balance a little bit more complicated problem. Next. So up here, we have a harder version of the same problem. So let's take our inventory. Left side, I have 3 carbon, 8 hydrogen, 2 oxygen, and on the right side, I have 1 carbon, 2 hydrogen, 3 oxygen. So since oxygen is the most complicated, I save it till the very end. So I could start with the carbon or I can start with the hydrogen. It doesn't make a difference. Just don't start with oxygen because it's in more than 2 locations. So carbon, first one, put a 3 there. That brings my carbon up to a 3. But it also gives me 3 times 2, 6 oxygen plus 1 over here, 7. Don't worry about that, because it's going to change again when I fix the H's, so it's just an accounting issue right now. So now I need 8 hydrogen on the right. So I put a 4 in front because 4 times 2 gives me 8. But that also gives me 4 more oxygen. So I have 6 here and I have 4 here, so the oxygen adds up to total 10. So now I need 10 oxygen on the other side. So I put a 5 in front and I get 10 oxygen. And so that's how it works. And then this one that I didn't touch is a 1. So then this ends up being 13 for the coefficients. Okay, next problem. This one, not that bad because it's one thing breaking up. So we have 1 Mg, 2 N, 6 O's on the left. And then we're going to have 1, 2, and 2 on the right. Now, since oxygen is in only 2 locations, you could do this. You could do oxygen first, you could do it last. It wouldn't make a difference. The order that you solve these in doesn't really matter anymore. So for this one, let's fix, well, the only thing we have to fix is oxygen, right? So I need 6 oxygen. I put a 3 in front. That gives me 6 oxygen. And guess what? I'm done, because my Mg's are balanced, my N's are balanced, and my O's are now balanced. So this would be 1, 1, 1, 3. Total would be 6. They can be that easy. All right. Next one. This one looks complicated, but it's really not. So here's the reason why. If we look at this, we would say, well, oxygen's in everything. So every number I put in here is going to mess with my oxygen number. true, okay? But rather than keeping track of all the atoms individually, we are going to use a little trick to make this much easier. Table E on your reference table is called the Polyatomic Ion Chart. So basically, polyatomic means multi-atom, and then ions, so anything with charge. So these are things with charge that are made up of multiple atoms. They like to stay together, and they do not like to break up. So whenever you're dealing with a polyatomic ion, you can actually treat it as if it were one individual element. So if we look at this one right here, you should be able to see that OH is on the polyatomic ion chart and SO4 is on the polyatomic ion chart. Now, it's not just enough to say, well, they're on the polyatomic ion chart, so I can treat them as one thing. Here's the other issue. They have to stay together, meaning I have SO4 on the left and I have SO4 on the right. Here I have OH on the left, that's why I highlighted them, and here I have OH on the right. Technically, NO3 is a polyatomic ion, so on this equation, you would think that you could do that, but you cannot because the NO3 does not stay together. It breaks up into individual N's and O's, so it doesn't work. This trick only works if the polyatomics stay together on both sides of the arrow. So instead of treating it as individual O's, H's, S's, and O's, I'm going to treat it as just an OH unit and an SO4 unit. So let's take a look. I have one calcium, I have two OH groups, I have two Fe's, and then I have three SO4s, and that's the left side. On the right side, I have 1, 1, 1, and 3. So now, start anywhere you like, it doesn't matter, because we're not worried about individual O's, and we are just going to keep track of the groups, and so fix what you see. So the first thing I see that looks super simple is I'm going to fix the Fe's. So I have two Fe's on the left, I need two Fe's on the right. So put a 2 there, that gives me my two Fe's, but it also gives me 6 OHs. I'm not going to worry about the 6 OHs yet because I needed to fix the Fe. So if the OHs go high or get larger, then don't get freaked out. It has to be that way because you need to make the Fe's balanced, and you can only multiply up. You can't divide down to make these numbers get smaller. So next problem. Let's do the SO4s. So I have 3 SO4s on the left. I need 3 on the right. So I have to put a 3 there, which gives me 3 SO4s, and it gives me 3 CAs. Again, the CAs were balanced, and now they're not. I'm not going to worry about it, and I'm just going to now fix the next problem. So the way I fix the next problem, let's fix the CAs. I have 3 on the right. I'm going to need 3 on the left now. So I put a 3 in front, and look what that does. That gives me my 3 CAs, and it also gives me 3 times this 2, which gives me 6 OHs, and now the equation is balanced. I've got 3 calciums on both sides, 2 irons, 6 OHs, and 3 SO4s. That's a 1. And then the sum of my coefficients, and again, the ones can always be left blank, but I like to write them in just as force of habit. Sum of my coefficients is 9. So this last problem, we're going to call it extra credit. This is the hardest balancing type of problem you're ever going to get. So let's take a look. 5, 10, and 2. That's my inventory. And I get 1, 2, and 3. So let's fix some problems, right? I need to put a 5 there. Gives me 5. I need to put a 5 there to bring that up to 10. If I retotal my H's, notice I'm doing this, I'm combining the step just because I've done this so many times. If I retotal my H's go to 10 plus 5, 15. And then I would need to go back and get 15 O's on the left. Now here's the problem. Because it's O2, right? If I put a 7 here, I'll get 14. And if I put an 8 here, I'll get 16. So the number that I would really need is 7.5. But you're not allowed to use halves. You have to use whole numbers in a balanced equation. So 7.5 doesn't work. So then you'd say, well, there would be 2 options. Either this equation can't be balanced, which if the equation isn't right, and like if the actual chemical equation isn't written right, that could be true, but we're assuming that it's written right, so it can be balanced. And then the other issue is, well, the one thing I didn't touch, maybe I should. Meaning I assume that this was a 1, but maybe it's not a 1, and that's why this problem is so complicated. So in order to really solve this, watch what happens. If I make this a 2, that's going to give me 10, 20, and still 2. And then as a result of that, I'm going to need double the amount of H's. So instead of a 5, I'm going to need a 10. And I'm going to need double the amount of carbon. So instead of a 5, I'm going to need a 10. That should be a 10 there. Okay. And that is going to double my amount of oxygen as well. So instead of 15, if we count it out, I've got 10 plus 20. I have 30 oxygen. And now if I go back, what times 2 gives me 30? 15 times 2 will give me 30. So sometimes the balancing numbers can be this large, okay? The sum of these coefficients would be 10, 20, 35, 37. So that is as complicated as balancing will get. I will probably never give you anything that hard. It will be more along the lines of all the other problems. The last thing we are going to do is going to be some of the practice work. So this is one of the practice sheets that I have. So I'm just going to walk you through a couple problems. The one thing to be aware of, it says show all work. So what I mean by that is I want to see an inventory. So just like you've done normally, I want to see, okay, I have 2 hydrogen, I have 2 nitrogen, I have 1 nitrogen on the right and 3 hydrogen on the right. So I want to see this type of work. I'm going to actually do this problem with you because this it's not that hard, but just in case. So it doesn't matter which problem you're going to fix, but if you look at it, the hydrogen are the biggest issue because 2 can't multiply. I can't multiply something by a 2, at least a whole number, to make it a 3, and I can't multiply a whole number by 3 to make it a 2. So if I wanted to fix the hydrogen, I'd have to go to their first common factor, which would be 6. Now, you could do that if you saw that happening, but you could also just fix the nitrogen first. I have 2 nitrogen here, so I'm going to have to put a 2 there. That's going to bring my nitrogen up to 2 and my hydrogen up to 6, which is the first common factor anyway. And then I go back and I put a 3 in front of the H2, which brings it to 6 as well. So one thing to keep in mind when you're doing these problems is just be aware that if something looks too complicated, I usually just say leave it till the end. And then if you fix all the easy stuff, the complicated stuff will typically simplify when you're done. So that's the type of work I want to see when you're doing these problems. I'm not going to do the next one. And be aware with polyatomics, just be careful. ClO3 is a polyatomic. It is found on table E, but because it doesn't stay ClO3, I can't keep track of it as a group. I have to keep track of it as individual Cl and individual O. On number 5, this was one I wanted to do with you, they do stay together. The PO4s stay together, the NO3s stay together. So when I keep track of this one, I'm going to look at it like this and say, okay, I have 1 aluminum on the left, I have 3 Ks on the left, I have 3 NO3s on the left, and I have 1 PO4 on the left. And then on the right, I have 1 K, 1 NO3, 1 Al, and 1 PO4. So now I just need to solve this. So whether you do the K or the NO3, it won't matter. In order to get those to be a 3, I have to put a 3 in front of here, which will give me 3 Ks, 3 NO3s, and then the entire equation is balanced. You could leave it like this, or you can put the ones in. But that's how to do balancing, and that concludes our balancing chemical equations video.